was able to ground it in a scientific basis, it smells like, and how it makes you feel when you feel it. Just to smell it. Does it make you feel good? Is it, you know, how does it affect whether you like it or not? Okay. So how does I'd like to introduce Dr. Bill Curtin, my research partner. And
we obviously don't have that much time, so we're going to kind of focus in on three basic, thousands of different kinds of odors very, very sensitively and accurately. How can you do that? I know that. So we'll look at a little bit of that evidence also. So let's start. They'll go into this. They'll find their way through this mucus layer and interact with some in the cilia shape, which would be recognized by a receptor that is embedded in the membrane of those little cilia that are just extensions of the nerve cell. And that affects another protein, and you get a sort of cascade of chemical events. Ultimately, enough said about that. This is how we generate anybody. Okay.
Where's it go?
In the original idea was it would accept only this particular odorant molecule, and therefore you need a different receptor.
So how many of you thought it was relaxing? Okay. That is interesting also. Think about the blue one. That was the middle blue. It's a tree that grows in the Amazon rainforest, and it is an oil that is relaxing. It's very meditative. It's kind of in the middle. The plant is lavender, and there's lots of lavender growing in Texas. There are lavender farms up in Blanco, and so you can go see the plant lavender.
Odorant molecules, and don't worry if you have not had much or any chemistry at all. It's not a problem. And so anywhere you don't see remarkably similar except for a bond here in this molecule that's not there in that one. And then this OH group has moved position in the molecule. Aromas from those three formulas have the same number of carbons, same number of groups, are arranged on the molecular skeleton. And so the blood. But my right hand, which would be that other isomer over there, receptor fingers in the protein were ordered to the sun harvest and sell it as essential oil. And make a lot of bucks in the process. But you can see it has maybe 10 different components.
Would the spiking be the same?
In the lab, all I would do would be to make
for olfactory senses.
Right. Spicy and strong. And then the other thing you need to consider is where the plants were grown. And another thing that would add to the complexity is this is one rosemary for remembrance. If you've taken freshman English and read Shakespeare, rosemary for remembrance, and this simply because it's all the same. It's all made in the lab, cold express. People just peel the orange and then squish the peels, and the essential oils comes out. So all of your citrus oils are very inexpensive because it's very.
And this is a picture of the surface where the molecules can sit down in there, so those little molecules could fit into those spaces. Now, this picture worked on this problem, and they were able to clone the genes for the receptor, for the olfactory receptor proteins. Is that a problem? If you remember that these receptors is designed to recognize an odorant of that particular shape. Now, when any of the odorants binds to its cognitive C major chord against C major, right? Okay? So little corners off of my triangle. I'm going to change the shape of that a little bit. We've got a musician in here who can play guitar. Yeah. Oh. Think about this now, not just in terms of what's happening in your nose.
And have the same kind of effect. It's used by massage therapists. It's called eucalyptus oil smell. And instead of bringing them, you know, flowers in the hospital, they're in a demonstration in a few minutes about how we can use them in other ways. But this will give you some combinations. One of the combinations is this. If you have stinky sneaks.
Okay. It's got a number of places where these, okay. These are all ideas that just follow very well from this basic model. And as we showed in our big sniff of it, really get your nose into the bag and inhale a lot of those molecules. What would you possibly do? Well, your nervous system. And then there are all sorts of other interesting ideas. There are people who are anosmic. They can't, that has to do with aromatherapy. Okay? All right. So let's talk a little bit about biology, just all over the place, but close to 100 patients who have cancer. Now, but there are studies that have been done and have been published, elderly patients. And of course today, as the population ages, affecting their ability to relax, change the mood of the patient, genetic studies on humans, probably not yet. Eventually, maybe, effectively at all. You can imagine what effect. To measure the effects of distress and the purported relief of the stress at the molecular level. Pretty well stressed out based on the levels of these. By affecting your system, your olfactory system in this manner, you are probably affecting the expression. Some of them were unaffected. And then when you put in the oil, it reversed that in the interest in use of these oils for medicinal purposes. You just don't do that. You just, you have to separate. Now, obviously, there's a little problem.
Is dependent on air currents, but then what do you do when you control it? Do you have them up there on also? Or do you know?
Half of the salts in this bag and half of this bag all move in like that along that edge. Perfect. And tie it up. Just make really nice. Email us if you have other questions, and Dr. Dinsky knows how to get the pictures. It was a good morning. Thanks for inviting us.
So the next time somebody puts you in a plastic tube?
I have a library. Just look on Amazon and find something simulated, as Dr. Crick was describing. If you can smell coffee beans, or even a cup of coffee works pretty well.